So good morning to chairman and person on dice and participants. So basically, my study is basically related to the like generation of you can say the discharge or sediment. So I am introduce myself, Dr. Mohit Kumar, working as a assistant professor from Punjab College, Chandigarh, and last 13 year I'm in a academician, and I have studied number of watershed in the Himalayas, and I have as per my understanding. So basic, you can say that just understanding of the watershed is very important. Means how the particular watershed behave, that is very important. Like if I'm perform like how the flood is generated, and when flood is coming, so it not coming alone. So it actually coming with lot of sediment. So sediment transport as well as or flood, that is the basic problem. So understanding of the watershed is very important. So yeah. So basically, how we can analyze the watershed. So morphometric, you can say that measurement and detailed assessment of landform through through mathematical measurement. So measurement, you can say that uh, to analyze the linear, aerial, and relief aspects. So measurement in terms of three: linear means one dimensions, aerial means two dimensions, and relief you can say that as per elevations. So morphometric means measurement and assessment of landform of a particular watersheds, and it is not an easy task. It is very difficult to measurement of a particular watershed. So for that, remote sensing or GIS is, you can say that, is a very helpful uh, to overcome this challenge. So in the present study, Mahanadi River Basin, I have selected to fulfill the requirement. So why this study performed? Because watershed management is a critical for sustainable development, especially a region which is prone to erosion or sediment transport, sedimentation, you can say that. And geomorphometric parameters are critical to understand watershed behavior, including runoff, stream discharge, means how much particular discharge coming from a watershed, and sediment yield. Uh, so these are the needs of the study on the this. So literature reported that significant volume of sediment reached the mainstream during the monsoon season, and informal tributaries. Despite valuable stream, a few study has been performed uh, regarding the measurement of soil erosion and sediment production rate. So basic of this study, how we basically perform. So basically, area watershed is divided into number of sub-catchments, and after that, every catchment using remote sensing GIS software, ArcGIS, you can see the 10.4 versions. So after dividing the whole catchment into number of sub-basins, and important parameter are computed each sub-basin wise. Sorry. So this is my catchment area. So catchment area of Mahanadi River Basin. So region up to Hirakund Dam I have taken. So most of the part of this region in the you can say the Chhattisgarh region and Odisha regions, and Hirakund Dam. So up to so basically Mahanadi River Basin is divided into three zones. So if you consider up to the Hirakund Dam, it is flood free zone, and up to Hirakund Dam to Naraj barrage, it is a flood generating zone, and after that it is flood affecting zone. So the flood and sediment is the basic problem of this area. So these are the morphometric parameters. You can say the linear aspect, aerial aspect, as well as relief aspects. So stream ordering, stream length, mean stream length, bifurcation ratio, catchment relief, ruggedness number, drainage density. So these are the important parameter which ultimately affect the generation of runoff, or you can say that flood in a particular catchment. And these are the further. So total, you can say that total 24 or 25 parameters are there. And these are the methodology. So by using SRTM dam, digital elevation model, put into the ArcGIS software, and compute and you can say that computation of all the parameter using software, ArcGIS. So linear aspect, aerial aspect, and relief aspect. Okay, so first of all, this is the catchment area, and catchment area was divided into total of 8 sub-catchments. And these are the area, percentage-wise catchment, stream length, maximum, minimum elevation, and parameters. So these are the important geographical parameters of a particular sub-basins. Yeah, these are the relief, aerial, and linear aspects. So linear aspects, these are the measurement sub-basin wise, and further relief aspects sub-basin wise, and these are the aerial aspects. So you can say that total of 24 parameters are there. Now, how we can compute which parameter affected more to our flood as well as sediment production rate. So, so for this purpose, I have opted a technique that is, these are the general expression runoff and sediment. So based upon the, if you compute the value of RF you can say that that is foam factor, circularity ratio, or compactness ratio. And these are the graph which show the sediment as well as discharge in a particular catchment area over the all 4 sub-catchments. And these are the behaviors, like which parameter, which particular catchment show more drainage density, elongation ratio, circularity ratio, compactness ratio. So these are the simple aspects. So move on to this. Now I have to choose a technique that is principal component analysis. So this is a technique, means how we can compute which parameter affecting more to our sediment as well as discharge. So this is the process. First of all, prepare intercorrelation matrix, and then first unrotated matrix, and then rotated matrix. For that, there are number of softwares are available. Like you can do the same process in Excel, Minitab, or you can say that MATLAB. So first of all, based upon the all 24 parameters, so these are the intercorrelation matrix, means which parameter are, how these parameter are intercorrelated with each other. So after the intercorrelation matrix, you can say next one is total variation. So sorry, by mistake it was Bias mentioned, but it is Mahanadi basins. So you can see, so eigenvalue, variability, and cumulative. So you can say that, so these are the principal component, like F1, F2, F3, F4. So first for 5 parameter, we will consider almost 100% variability. So for the analysis purpose, I have considered 4 parameter, that is F1, F2, F4, or F3. So these are the principal components. So this 4 principal component, you can say that contribute almost 97% of variability. And so this is unrotated matrix and rotated matrix. So software automatically will give the behavior of your parameters. So these are the important parameters, like stream frequency, drainage density, length of overland flow, and if you look at the value of this principal component, so it will show is F1 0.827, so red one values. So this much unrotated matrix will take the correlations between the parameters. And further, so the total of, you can say the total of 24 parameters, but still unrotated matrix will not give the full understanding of that. And for that, you can say that it is like a mirror image. After rotating the structure, there is a provision in the software, you can rotate the figures. So next one is a rotated matrix. So rotated matrix will give the exact value, which parameter is affected more to our sediment or sediment production rate. So you can say that in the rotated matrix, the blue one value represent the correlations. Means these are the important component which affected our discharge or sediment production rate in a catchment area. So 0.87%, F1 0.986, 0.9410. So based upon this rotated matrix, so we can say that, so we compute the based upon the principal component, we compute, okay, what are the important parameter which affected our discharge or sediment production rate. So based upon this, so these are the prioritizations. So accordingly, we can give some rank to the sub-catchments. Means These are the important parameters based upon the rotated matrix, that is length of overland flow, compactness coefficient, circulated ratio, and then, there is a compounded value. So based upon this, the parameter is based upon the compounded value, which has the least value. We can assign rank 1. So rank means once runoff occurred in that particular area, so more sediment will come in that particular catchment. So in this way, so we can assign some particular rank to the sub-catchments. So these are the rank-wise rank to each sub-catchments based upon generation of discharge and sediment. So basic principle of basic purpose of using principal component analysis, that is we are going to reduce dimensionality. Otherwise we have 24 parameters, 24 dimensions. Then how we can reduce the number of dimensions so that we can reduce the dimensions, and as well as we can get the fruitful answer for that. So this is the basic of this study, means how we can prioritize a particular catchment after dividing it to sub-catchment, so that, for example, if we are going to plan any like a check dam or any dam, so in which particular region immediate attention is required. You can say that in terms of soil conservations. So based upon this study, we can say that, okay, if we assigned watershed number 4, we assigned rank 1. So we can say that if we propose any hydraulic structure in that particular area, so soil conservation is immediate required in that particular area. So this will give the preliminary study, means before planning any water sources management or water sources structure in a particular region where we assign where soil conservation is required. So that is the basic purpose of my study. So these are the conclusion. Yes, morphometric parameter are a reliable indicator of geological, geomorphological relief, slope, climate, and hydrological dynamics in a particular selected catchment area. The study examined the morphological and hydrological characteristics across diverse morphoclimate setting while evaluating variation in morphometric parameters. So among the 8 sub-catchment, sub-watershed 4, 2nd, and 7 are the rank 1, 2, and 3. So immediate soil conservation is required in that particular area because this area is highly prone to sediment production as well as discharge. So PCA-based prioritization provide a more efficient, effective methods accessing the morphometric characteristics of a sub-watershed on their relative hydrological behavior, offering critical insight for sustainable management. So these are the end of my presentations. Any questions? Yeah.